Okay, now let us see this question. A system with zero initial conditions, has the closed loop transfer function of this. The system output is 0 at the frequency. System output. So that means at what particular frequency the system is not able to generate the output. So first let us take the transfer function T of s is equals to s square plus 4 by s plus 1 into s plus 4. At this particular frequency, what is that? A or B or C? At this particular frequency, the output of the system is 0, which is nothing but, can I say, y of s by x of s, right? So the output of the system has to be 0 at particular frequency. Now what you need to do, put s is equals to j omega. Put s equals to j omega. Then what is our transfer function? T of j omega is equals to j omega whole square plus 4 divided by j omega plus 1 into j omega plus 4, right? Wherever s is there, we just kept that j omega, which is equals to what? Y of j omega divided by x of j omega. Now output has to be 0. Output has to be 0 means the numerator part of this transfer function should be equal to 0. So if it is 0, then we can say that yes, the output of the system at this particular frequency, it is 0. So now can I say put or else equate what is j omega square? J square omega square. J square value is minus 1. Minus 1 into omega square minus omega square. Minus omega square plus 4 equals to 0. If this component is 0, automatically the output is 0. So what frequency we are going to calculate? Therefore, can I say omega square is equals to 4, then omega is equals to plus or minus 2. So frequency can't be negative, right? Therefore, can I say frequency omega is equals to 2 radians per second. 2 radians per second. Therefore, what is our answer? This is our answer. This method is very, very important, and you just consider this is as very important concept. Okay, consider this is as very important concept. Kindly look into this. This is very, very important. Very, very important. Okay, very important model it is. Like this kind of model question was asked in GATE also and engineering services prelims also. Okay, now let us see the next question. Okay, read the question very carefully, and this is so important model, and generally we will commit a mistake, and what sort of mistake is we will see. Okay, they have given open loop system. Okay, and this is the transfer function they have given. Now what they are asking? They are asking to calculate which of the option is correct. Stable minimum phase, stable and non-minimum phase, unstable minimum, unstable non-minimum. So first of all, what is meant by stable and unstable? First let us see the condition for stable. How can you say whether the given system is stable or not? So whenever, if any poles or pole is lie on right hand side of S plane, then we can say the system is unstable. Then we can say the system is unstable, then the system is unstable. Else the system is stable. Else the system is stable. Okay? So this is the definition of a stable or unstable definition. Next, minimum phase and non-minimum phase system. Put a heading minimum phase. Minimum phase system. What is meant by minimum phase and non-minimum phase system? If any particular system has certain poles and zeros, right? Any system has certain poles and zeros. If all the poles and zeros, if they are lying on left half of plane, that is called minimum phase system. Okay. If any pole or zero lying on right half of plane, then we can say what? That system is called non-minimum phase system. What is that? Non-minimum phase system means what? No pole or no zero should not lie on the right half of plane. If any zero or pole or both, if it is lying on right half of plane, that is called non-minimum phase system. If all are on left half of side, that is called minimum phase system. You see, if any pole or zero or sometimes both lie on left half of any pole left half nahi, right half of S plane, then we will call it as a non-minimum phase system. Then we will call it as non-minimum phase system. Else we will call minimum phase. This is the basic meaning of what is minimum phase system and what is non-minimum phase system. Okay. So by the definition, you see poles. These are the poles now. Poles are lying on left half of plane. So first statement is true with respect to stable. So with respect to poles, one thing we concluded that yes, with respect to poles, one thing we can conclude that it is stable. But if you observe the definition of the minimum phase and non-minimum phase system, no pole and zero, any pole and zero lying on right half of S plane, then we can say it is called non-minimum phase system. You see poles are on left side, no problem. But if you see the zero, S minus 1 means it is lying on, or if you want me to plot that, this is, okay, let me erase this. Yeah, this is 0 at minus 1, pole at minus 2, another pole at minus 3. So for this particular thing, you can say system is stable, and also you can say it is a minimum phase. But the problem is 1 0 is lying on right hand side. So therefore, because of this, we cannot say the given system is minimum phase system. It is a non-minimum phase system, and zeros anyway it will not affect the stability of the system. So therefore I can say it is stable and non-minimum phase of the system. Okay. Yeah. So always remember this statement. Simple thing. Non-minimum phase system means either at least one pole or zero should be lying on the right hand side. Else it is a minimum phase system. And no pole should lie on the right half of S plane. Then we can say it is a stable. Okay. So please take it. Now let us see this question. What is that? The transfer function of a system has the form g of s is equals to 200 s plus 2. What is that? G of s is equals to 200 into s plus 2 divided by s into s square plus 10s plus 100. Correct na? Now what is it asking? At very high frequencies, the Bode gain curve has the slope of. So we need to identify what is the Bode gain curve slope. So first identify the poles and zeros. So let me say poles are, one is S, and what about this corner frequency of this particular characteristic equation? Is it looks like a s square plus 2 zeta omega n s plus omega n square? Yes or not? So from this, can we calculate what is omega n? Yes or not? Omega n. So how to calculate the omega n? So let us say one is about 2, one pole, its corner frequency is 10. Can I say that? Why? Because omega n square is equals to 100. From this, omega n is equal to 10 na? So one pole is at 0, another one is at 10. So minimum corner frequency. First corner frequency is very low corner frequency. Generally we cannot say 0, but it is for understanding purpose. Pole at origin, and its corner frequency is 10, but it is having a 2 poles. Because it is a second order system. Now what about the zeros? Zeros can we say at -2? At -2, can I say that? So therefore the slope, now we are going to calculate the slope. Okay, at pole is equal to 0, pole at origin. What is its slope? Minus 20 dB per decade, because it is the minimum, it is the what? Initial slope. Now another pole and another 0. So what is the minimum corner frequency here? This is the minimum corner frequency at 2. What is at 2 corner frequency slope? Plus 20 dB per decade. Or here they have given octaves, either minus 20 dB per decade or 6 dB per octave. Okay, minus, and it is also plus 6 dB per octave. Okay, now this thing for 10, how many poles it is? 2 poles. 2 poles means minus 40 dB per decade, or we can say minus 12 dB per octave. What is in the question? At very high frequencies, the Bode gain curve has a slope of. If you draw its Bode plot, approximate Bode plot, this is. Initial slope is how much? Minus 20. So minus 20 means like this. And first corner frequency at 2. At 2. Second corner frequency at 10. So this is minus 20 or minus 6. Anything you can write. So at 2, 1 0 is adding. 1 0 means plus 6 dB. Minus 6 to plus 6 will be 0. At 10, 2 poles, which is nothing but minus 12. Minus 12 octave. So therefore, at highest corner frequency of the Bode gain curve, the slope is minus 12 dB per octave. So this is your answer. Okay. So in TRANSCO GENCO, what they will ask is simply either they will check like this kind of questions, or generally they may ask you, like they will give you randomly a plot. From the plot they will ask you what is the gain at this particular frequency. Then you have to use the slope method. This is, you will call it as initial, let us say initial guess. This is, let us say this is x1, this is x2 means this is y2 and this is y1, right? So you know that slope formula, y2 minus y1 by x2 minus x1, which is nothing but slope minus x dB. From that you can calculate y2. Okay. Let us see this. Which of the Bode asymptotic plot shown in the below figure is correct plot for g of s is equal to k by s square plus k by s square into s plus 5. First let us take the transfer function. Let me take it as the g of s k by s square into s plus 5. Can I say this? Yeah. So you tell me how many poles at origin is there? 2 poles. Pole at origin. 2. Pole at or simple pole. How many? Minus 5, which is equals to 1. Number of poles at minus 5 is equal to 1. Pole at origin is equal to 2. Therefore, total 3 poles. Therefore, overall expectation will be minus 60. 20 minus 40. Total overall minus 60. Okay, na? So now, first of all, we need to identify the corner frequency. What is the first corner frequency? Can we say that the first corner frequency is at minus 5? Or first corner frequency at 5? Is there any initial slope? Yes, this is the initial slope. This is called initial. This is called initial slope. What is initial slope? Double pole at origin, which is nothing but minus 40 dB per decade. Oh, let me erase this. Minus 40 dB per decade. Minus 40 dB per decade. Or we can also write minus 12 dB per decade. Both, sorry, minus 12 dB per octave. Both are correct. Now, at this corner frequency, you are adding one more pole. One more pole means its resultant will be further steep, which is nothing but minus 60 dB per decade, or we can say minus 18 dB per octave. Okay. So, which of the following option is correct? So, I can first of all straight away eliminate these two. Okay. Out of these two, one is correct. Minus 6 to minus 12. No, minus 12, minus 18. So, obviously the answer is B. Right. So, therefore, option B is correct. So, only thing you need to identify the corner frequency. Corner frequencies means what? Simply poles. You just remember like this. Corner frequencies is nothing but only poles and zeros. Okay, fortunately here there are no zeros, so straight away we can mark only negative slope will be coming into the picture. So therefore minus 40, minus 60, but you can say out of these two, but this is not a pole. 1 by 5. Poles and zeros straight away you have to take. You need not to do anything. When you have to take this, when you are representing the transfer function in time constant form. Generally what they will do is they will give you this kind of Bode plot and they'll ask you to reframe its transfer function. Then you have to take like this 1 by 5 form, like time constant form. Okay? So I hope this is clear. Read this question. The Bode asymptotic plot of a transfer function is given by the transfer function has. Just now I told you. The question which we have solved previously, transfer function to Bode plot. Now we will do Bode plot to transfer function, but here we are not deriving the transfer function, but we are identifying the poles and zeros. So let me redraw the same. Okay, so follow very carefully. Okay, so this is nothing they've mentioned means what? It is flat line. So this is 0 dB. All are dB per decade. Simply I am writing like 0 only. Another one is 40. Another one is 20. One thing is very clear. Here you have one corner frequency. Here you have one corner frequency. That is where the slope is changed. Let us say this is x1 and this is x2. If you observe one thing, the initial slope of this Bode plot is 0. initial slope of the Bode plot is 0 means there is no, or you can say there are no pole or 0 at origin. There are no pole or 0 at origin. But if you observe very carefully, at x1, the slope is changing from 0 to 40. The slope is changing from 0 to 40. That means to the 0 you added a plus 40 dB per decade. Plus 40 dB per decade means at x1 how many zeros are there? We can say for plus 40 degrees. Resultant slope is 40 dB per decade. So 40 dB per decade means what you have added there? 2 zeros. 2 zeros at x1. 2 zeros at x1. And slope is going on at x2. At x2. At x2 the slope is now changed from 40 to 20. That means what? 40 to 20 means it is dropped down. It is dropped down. You can say 20 minus 40 also you can say. So now 40 to 20 is changed means minus 20 dB per decade is added. Minus 20 dB per decade you have added this at x2. Minus 20 dB per decade you have added means how much? Which is nothing but 1 pole. Simply we can say 1 pole at x2 you have added. So therefore here you added how much? Minus 20 you have added. So plus 40 minus 20 resultant is plus 20. Clear now? So therefore 2 zeros and 1 pole. So 1 pole 2 zeros. This is the correct answer. Right? So remember, it's very important whether you have chosen dB per decade or dB per octave. They may ask you this is in another way. Instead of asking 40, they may ask you like 12. They may ask you this is 6. 12 per octave. 6 per octave means 6 dB or 12 dB per octave. If they ask also in the same way, we can solve it. Okay. So I hope this problem is clear. Now let us see next question. A unity feedback system has open loop transfer function, polar plot g of s is shown below. The gain margin and the phase margin of the feedback system is. Okay. So first of all, they have given this plot. If you observe in this plot, it's very clear that this is the point of intersection. This is called what? Point of intersection. And this is what? The angle at which the plot is making. The angle at which the plot is making. So what is they asking? Simply gain margin how much? Phase margin how much? Okay. So in polar plot, the gain margin definition is 1 upon point of intersection, POI, point of intersection. So here the point of intersection is at what point? Minus 0.3, or generally we will call it as 0.3. So what is that value? 1 upon 0.3 magnitude. So simple. Magnitude, where is that point of intersection? 0.3. That is called PY. So can I write it like it is 10 by 3? 10 by 3 means how much? 3.33. 3.33. Clear enough? On the other hand, they have given at what particular angle this plot has been drawn? At omega GC. At this particular omega GC, what is the angle? Because the phase angle we are going to calculate at where? Gain crossover frequency only. Now can you tell me what is the angle we got? Now phase margin. Phase margin we are going to calculate at gain crossover frequency. At this particular gain crossover frequency, what is the angle we have? This much. We know that phase margin is equal to 180 degrees plus angle G of S H of S at omega GC. Very important. Where about gain margin, we are going to calculate at phase crossover frequency. You know that, right? So now you tell me, as per the question, if you observe very carefully, at omega GC, what is the angle made by the system? Minus 112.33 degrees. Now what is the resultant? 180 degrees minus 112.33 degrees, which is nothing but 67.67 degrees. Okay, therefore the option is C. Remember, if you want to write, you can write, put a note here always. Gain margin is always at omega PC. Phase margin is always at omega GC. That's it. That's it. If you remember these two, and you know that gain margin is nothing but reciprocal of point of intersection, and phase margin is 180 degrees plus angle GS HS. That's it. If you do these two, the problems are very easy with respect to the polar plot. This sort of questions they will ask, and also they may ask you the question like whether the given system is stable or not. For the same question, if the given system is stable or not means, is it enclosing minus 1 plus J0? Enclosing is this one only, na? This is the direction, right? So minus 1 plus J0 is here. So it is not enclosing minus 1 plus J0. Therefore the given system is stable. That's it. Okay? I hope it is clear.